In this video, we'll be looking at page 42 about types of triangles. And the anchor piece looks something like this. This is how it appeared before it was folded. I'm not going to be using this particular piece because I can't open and close the little doors. I'm going to be using the inside of them. So as we open up the doors, I want to show you some things about these triangles. Before we get started, though, I want you to know a very important rule. All triangles have a total of 180 degrees. So those internal angles on any triangle will total, they'll add up to 180. So let's open the door for scalene. It's the green door. And that will correspond to the green triangle. Scalene triangles have no equal sides and no equal angles. And if you take a look at this diagram, you can count the tick marks to know when things match. So you see that one side has one tick mark. Maybe it is, I don't know, this kind of looks like a 90-degree triangle. I'm not sure if it is or not, so let's just pretend that this is 80. This is 60, and then this would be 40. So you see that none of the angles match, although they would add up to 180. That must be true. But because none of the angles match, none of the sides will match. So this one may be 15 feet. This one may be 18 feet. And maybe this one is 12 feet. I'm just making up numbers. But I do know that none of them match because it is a scalene triangle. No equality at all on this one. Okay, the next one is that aqua blue color. It is the isosceles triangle. Isosceles triangles have two equal sides and two equal angles. Base angles are always equal. So if this is 20 yards, that one tick mark corresponds to this one tick mark. So that tells me that those two are equal. And then these two little lines down here at the base angles are telling me that those correspond, meaning they're the same. So maybe this is 70 degrees and 70 degrees. Base angles are always equal in an isosceles triangle. And then this one is called the vertex. So if we do the 180 for the whole thing, that would mean that the vertex angle would be 40 degrees. Because 70 and 70 and 40 total the 180 degrees. It always has to pass the 180 degree test. Okay, then we should have equilateral. It's the yellow one. So that's this one. This is the square of the triangle world. And let me just tell you something here about the word equilateral. Lateral means side. Equi or equa means same. So equilateral is sides that are all the same. 3 equal sides, and then we have 3 60-degree angles. Has to be 60 because remember it has to pass the triangle test. And that is 180. And whatever I choose for those sides, it has to be the same. So maybe I'll do 5 all around. Equilateral. And then we have an acute triangle. That means that all of its angles are less than 90. So for example, we could have an 80, a 60, and a 40. It still has to pass the triangle test. So 60 plus 40, that's 100, plus 80 is 180. I can tell you that this particular one is scalene because none of the angles match. So none of the sides would match. We could have maybe 16 yards, 18 yards, and 14 yards. If the angles don't match, the sides don't match. Moving on to right angle. This one has one angle that is exactly 90 degrees. That is designated. Most often there will be one by a box here. Sometimes it's shaded, sometimes it's not, but that indicates perpendicular. So that is 90 degrees. And this one looks like about 60 and maybe 30. So 90, 60, 30 is 180. None of those angles match, so we could also call this one scalene. You can also very commonly have right isosceles, and I'll show you one of those. Let's come down to the bottom of the page here, and let me draw you a right isosceles. So if it's right, it has to be perpendicular in this angle. And I overshot just a little bit. So this is 90 degrees. And then this, let me patch it up there a little bit, would look like this. If you see something this way, that means that we have isosceles. That means that these two angles would be 45 degrees, and they have to be 45 because the vertex angle is 90. So 45, 45, 90. So this is a right one because of the 90 degrees. It's isosceles because of the two base angles. So it is possible to have a right isosceles or a right scalene. All right, back to this one, the orange one. These are the ones that gave me trouble for some reason. This is obtuse, and it's right down here. One of its angles is greater than 90, so you're going to have that very wide angle in here. And this looks like about a 120. But this one, because that angle is so big and it's taking up so much of the other angle, you could have a 30 and a 30. So you have 120 plus 30 plus 30. So that's 180 total. And it's isosceles because two of the sides are the same. These two would be the same. Those base angles are the same. But as long as you have that one very big angle in there, that's the obtuse angle. It is an obtuse triangle. So triangles can be named by their sides or by their angles. Your choices for sides would be scalene, where no sides are equal. Isosceles, where two sides are equal. And equilateral, where all sides are equal. If you want to name them by angle, you would either have all acute angles, less than 90. You can have a perfect right angle, or you can have one angle that's more than 90. So you can name a triangle by the sides, by the angles, or by side and angle, like we did with this one. This is by side, and this is by angle. I don't think this is going to be a big deal on the HESI exam as much as the fact that triangles have 180 degrees. I think that's important to know on any math test.